the first question. If an applicant is selected at random, what is the probability that the person is qualified and will pass the test? So here's where we are at. We're picking somebody at random. Do we know anything about them? No, they come from this general population. And what we want to know is what is the chance that first the person is qualified and they will pass the test. They will meet both things that we want to happen. So the way I'm looking at this tree is we're starting here at this node. And we want to know the chance of going from here and then later to here. So the way we think about it is this. I'm going to write this first, the question in function notation. Always write your questions in function notation and you're given information in function notation. So this is do job and pass. What's the chance of this happening? And now I'm ready to just interpret the tree. Again, starting here, is it 80% chance you'll be able to do the job? In other words, of the starting population, 80% will come here. And then once you find yourself in this position, 85% of the remaining will pass the test. So in other words, of the whole one, 80% will be able to do the job. And then 85% of those will be able to pass this test. So in other words, there's going to be a 68% chance of finding somebody and having these two events come to pass. So let's ask ourselves another question, see how this works out. What is the second question? Well, what's the probability that I pick somebody at random and that this person will pass the test? Wait a minute. Just pass the test? I'm going to pick somebody at random, pass the test. Do I know anything else about them? No, I don't know anything else about them. So now I'm realizing that 85% here is not passing the test. This is passing the test if you can do the job. This 2% here is not passing the test. This is 2% of people who are not able to do it. They will pass the test. But this is just pass the test. In other words, if I write this using function notation, this is going to be pass, period. How can I get somebody to pass the test? Well, if I'm grabbing somebody at random from the population, there's two ways they can pass the test. One of them will be they are able to do the job and to pass the test. In other words, this right here. This is one possibility. So out of the 100% of people, 80% filter through here, and then another 85% filter through the passing stage. Now, another possibility is, which these two things are completely disjoint, or here I'm not able to do the job. This is a completely different set of people, but some of them will pass. In other words, of the 100% of the population, 20% of those will not be able to do the job. And then of the remaining 20%, 2% of them will still pass this test. The result of this calculation is your ability to pass this test. And you notice this results in about 68.4% being able to pass a test, which is just a slight increase from the previous answer of 68%. In other words, there's still going to be a small portion of the population that's going to pass this test, yet you don't want to hire them. Overall, not much different from just finding a qualified person and then passing the test. So to reiterate, why does this make sense? Because I have two paths that lead to what I want. One of them is able to do the job. Once you're able to do the job, you can pass a test. Or another possibility, disjoint from that path, is not able to do the job and pass a test. I want to now break down what we just did, these two problems, because it leads to a formula in your formula sheet. And all of a sudden, this is where problems begin to start later on. You'll notice that when I use these and earlier, when I introduced these conjunctions, The and just means what's common to both of these events. In other words, one person has to meet both these criteria. That's all the and means. And is a conjunction. These are two separate events, and we want to find somebody that meets both of these criteria. And right now it says in the population there will be a 68% chance of finding somebody that can meet both criteria, doing the job and passing. And now I took this product, but I want to again make clear what this product is. If I break it down into its steps, it gives you my general formula for finding the probability of one event and another event. But let me warn you, this is not supposed to be the only way. I'm just saying it is a way. Now, some people say, well, because it's a formula, now it must be the only way. It is not the only way. It is just saying that if you happen to have this information, which in this case we do, then go ahead and perform these steps. You'll notice when I first introduced the and, I never told you how to do it. I just told you what it was because the information provided was so simple that there was no way of getting confused. So when I created the tables, I said, what's the chance of this and this happening? And you went and grabbed the counts that corresponded to what we were talking about because you knew what to find. So again, this leads to the following formula. According to the tree, what I needed to have was the probability of do job times the probability of pass given do job. That's what it took to do this one. And there's a product. But the second part of this product has to be conditional. Conditional what? Conditionally based on the first product. Sorry, the first factor. Now, I'll come over here and break this one down. What is this one? Well, the first part is what I just did. It's this right here. And what is the second part? Again, notice the first part is not do job times the probability of, again, pass, but because my first one is not do job, this must be pass given that not do job. In other words, this second one better be conditional on whatever the first statement was. In this case, the first statement was not do job. And this leads us to this general way of calculating and. But again, to warn you, we only do this if we have the right situation, the right information. And here's my last attempt to justify this product business. I created again the similar tree, but this time I put some numbers in place. The number we can find here is 1, starting for 100%. This is to say that the population turned out to be 10,000 people. Then again, what the tree does is filter to 10,000 people. 10,000, or I should say 80% of 10,000 is 8,000. And then notice of this 8,000, how many will be able to pass the test? 85% of the 8,000 is 6,800. As a matter of fact, right now, if I were you, I would take a calculator and just do that really quick. 10,000 times 80% is 8,000, and then 8,000 times 85% is the 6,800. So what's the probability of do job and pass? Well, if I follow these steps and lead it to the end, it turns out that 6,800 out of 10,000 will be able to do both. Anybody here pass through do job and pass the test. 6,800 people did that. 6,800 divided by the total of 10,000. What does that number give me? 68%. So this is the same thing except with a count. Instead of 10,000 though, we did it with 1. So 80% of 1 is 0.8. 85% of 0.8, when I take the product, comes out to the 68%.